This is the solution to the SHM basic graphs and pendulum question. And as is so often the case, it begins with a definition of SHM. So the acceleration is proportional to the displacement from the equilibrium position and always directed towards the equilibrium position. Then we have graphs 1 and 2. Graph 1, the curve labelled A, shows how the displacement x of a body executing simple harmonic motion varies with time t. And graph 2 shows, the curve B shows how the acceleration A of this body varies over the same time interval. And you're to add to one of those two a curve labelled C showing how the velocity of this body varies over the same time interval. So here we have time equal to 0, x is a maximum positive. So at time t equal to 0, the velocity is going to be 0 because the object has got to its maximum displacement and it stops there. So v will be 0. Immediately after that, it's going to be moving down, so the velocity is going to be negative. So what we're going to have is a minus sine curve. So as it goes through x equal to 0, we're going to have a maximum magnitude of velocity. When it goes through here, it'll be a maximum positive value, and so on. So what we have then is a curve that looks like this. It's a minus sine curve. And which of the two curves show SHM? Well, it's A and B. The relationship between the acceleration and the displacement. And then finally, long simple pendulum has a natural frequency of 0.092 Hertz. What that means is if you set it in motion, that's the frequency. If you just start it and let it go, it will naturally oscillate with that frequency. What is the length of the pendulum? Well, our relationship for a pendulum is t is 2 pi root L over g. If we then make L the subject of that, because that's what we're after, it's L, so then we have L is g times t squared divided by 4 pi squared. And if we then stick in our numbers, we get that, and evaluating that, we get 29.3. And then we look and we say, how many sig figs do we have? Well, we've got 2 for the frequency. We've got 2 for G, so the answer should be 2. If we'd only had 1 for G, for example, or 1 for F, we'd have been down to 1 sig fig. If we'd had 3 for both, we could have done 3 sig figs, 29 meters to 2 sig figs.